Hey everybody, so right now I am working on the problem, remove duplicates from sorted array. So we're given a sorted array of numbers and we are told that we have to remove the duplicates in place such that each element appears only once and returns the new length. What's another way of saying that in like regular English? We just want an array that holds unique values and we want to remove the ones that do not hold the unique values. So they say, do not allocate extra space for another array. You must do this by modifying the input array in place with O of 1 extra memory, which means constant space. So we're not able to create a new array at all to return our answer. We have to do it all within the same array, changing the original array that was given to us. So here's an example. Given nums 1, 1, 2, your function should return length equals 2, with the first two elements of nums being 1 and 2 respectively. It doesn't matter what you leave beyond the return length. So basically what they're saying is that if the length is 2, right, what does length of 2 mean, right? So we know that this array is indexed at 0, so right, so 0, 1, 2. So that's the total like capacity that this array can hold. But what's the length of the array? 1, 2, 3, right? But we have a duplicate in there. If we didn't have this duplicate, then this right here would be 1, 2. So what they're telling us there is that we have to return length 2. So what is the length of the array if it were lacking any duplicates? That's the number we have to return, right? So they give us another example here. Your function should return length equals 5 with the first 5 elements of nums being modified to 0, 1, 2, 3, and 4 respectively. It doesn't matter what values are set beyond the return length. Confused why the return, it's a lot of stuff to read, whatever. All right, so this makes sense, right? So we're going to return the length equals 5 because we have 0, 1, 2, 3, and 4, right, in our array, which is 5 numbers, which is the length of 5. So how are we going to do this? Well, we can do it using 2 pointers, a reading pointer and a writing pointer. So one pointer, our writing pointer, is going to check, or our writing pointer is going to be writing numbers, and our reading pointer is going to be checking their unique values, right? So something that's important to remember is that we're trying to remove duplicates, right? If we're trying to remove duplicates, right? Let's say we have an array of 1, just an array of a single 1 in it. Does this array have any duplicates? No, it doesn't, right? Because if you only have one thing, then it is impossible to have a duplicate of that thing, correct? If it's 2, 10, if it's, who knows what number I just made, but that array right there has no duplicates because it is of length 1. So an array of length 1 cannot have duplicates, right? So then let's just do like, let's add another one, right? So then we have 2 things in here. Now it's possible, right? This array can have a duplicate, right? Because this can be here, right? Or we can have like, yeah, so that number can be there. So yeah, it's very possible that it's very possible to have a duplicate if there are 2 numbers. But yeah, so it's impossible to have a duplicate if there's only 1 number, correct? So now that we know that, let's take a moment to think. Let me just move this down real quick. We have our reading pointer and our writing pointer. Is 0 equal to 0? Yeah, so let's just think about this like in regular English terms, right? Is 0 equal to 0? Yeah, it is, so we wouldn't want to include it, right? But we're gonna write down our first 0. Like this 0 is gonna be there because, and remember we're working with the input array, right? So we're gonna leave this 0 as is, right? Meanwhile, this 0, we're gonna say, okay, that 0 has a 0 at the first index, right? So that right there is gonna be kept. Like we're not gonna add the 0 we're looking at right now. But then like is 1 equal to 0, right? We're gonna add the 1, and then we're gonna like 2, then we're gonna 3, then we're gonna 4. So what's that look like, right? Like in a more logical code-like process. Well, right here we have our writing pointer, right? And we here have our reading pointer. So the purpose of this is we're gonna have our writing pointer writing down the values, right? Entering the values that are unique, and our reading pointer is going to be looking for the unique values. So we're going to start off, right? And we're going to say, okay, our reading pointer is going to start off at, let me see, I can't click the stuff. Our reading pointer is going to start off at 1, right? Because, yeah, like it's going to start off at 1 because we already know that the thing at the first index, which is 0, is unique because everything that comes after it can be a duplicate, but the first number itself cannot be a duplicate, as I showed at the bottom. So now we're going to say, is the value at the reading pointer equal to the value of the writing pointer? No, right? So now we're going to move our writing pointer along further, right? Let me make a copy of this right here. I think that is really, really good to make a copy of, and replace this with that. So this is the array we're changing, right? So this is the original, and this is the one we can change. So we have our reading pointer right here, and we're going to start off here. Is 0 equal to 0? Yes, it is. So we want to keep going further along the array, and we're not going to do anything for our writing pointer because, well, we haven't found a new value. We're not doing anything, right? Okay, so here we have a reading pointer. Is 1 equal to 0? No. So the thing is, right, like, because 1 is not equal to 0, what do we do now? Well, we know that the value at the first index is always going to be unique. So we're going to be filling up the values at the second index, right? So this right here is going to become 1. And then this reading pointer right here is going to be at this 1. And then this W is going to move forward. Actually, let me just do this. Can I do that? All right, so I don't think I can do that with this program. Let me see if I can do it if I just remove this as much as possible. No, still no. All right, so this is what I'm doing. I'm gonna write it out. So here we have our reading pointer. No, it was right here. Here's our reading pointer. Here's our writing pointer, right? So then I'm also going to move this down here. So that's the original one, and this is the one that's being changed, right? So because we changed this to 1, we know that this value right here is not equal to the value 0. So we know we have a unique value from 0 and 1 because 0 is not equal to 1. So what we're going to do now is we are going to advance forward in our array for our writing pointer, and now our writing pointer is going to be here. So we're going to say, okay, we moved forward our reading pointer 1 before, we moved forward our writing pointer 1, and now we're going to say, like, okay, is what's at the writing pointer equal to the reading pointer? Yes. Keep moving forward our reading pointer. They're still equal. Keep moving forward our reading pointer. They're still equal. Keep moving forward our reading pointer. All right, now we have is 2 equal to 1? Or is 2 not equal to 1? The answer is yes, 2 is not equal to 1, so we want that to be our next value. So we're going to change the value right here to a 2, right? And then we're going to increment our writing pointer by 1. And then we're also going to increment our reading pointer by 1. You notice something, our reading pointer is always going forward no matter what, because it's independent of the writing pointer. The reading pointer is always going forward. We're always checking, are the values unique? The writing pointer is to write down the unique values, which doesn't always happen, right? So now we have a 2. Is the reading pointer equal to the writing pointer? Yes. Now here we have reading pointer. Is the reading pointer equal to the writing pointer? No. So we're going to change this one that's 1 ahead, right? We're going to change the number that's 1 index ahead of our writing pointer to be a 3. And then we are going to put our writing pointer right here. And then we're going to say, okay, then we're going to also move this one forward 1, as we should have done before. So then we say, All right, is our reading pointer equal to the writing pointer? Yes, so it's not unique. Now we go to our reading pointer. Is our reading pointer equal to our writing pointer? Nope. So now we have to change the value at the index 1 ahead of the writing pointer. Make this a 4. Move our writing pointer forward 1. And then move our reading pointer forward 1. And now we notice that the reading pointer is past the capacity of our array, or it's equal to the length of the list. So both of those are both true, just different ways of explaining it. And because of that, now we're going to stop. And then we're going to say, we were supposed to return the length of this array, right? Of all unique values. So the length of this array is the capacity of the array, which is, can hold up to index 4, right? Plus 1, which is the length. So then we return at the very end, like w plus 1, which is the length. And then our answer here is 5. If we look over here, 5 is the length we should have returned as well. So basically, that is how you do the problem. All right, so let's code this out. So I go back over here. What did I do? I started off, I remember, with my writing pointer equal to 0, my reading pointer equal to 1. I said, while the reading pointer is going to traverse until the end of the list, until it's equal to the length. So while read is less than length of nums, we're always going to be incrementing read by 1, remember? And then there's a special condition when we increment the right pointer. So if nums of right is not equal to nums of read, then I'm going to do nums of right plus 1, because the first value we work with is always unique. So you have to change the next one. Nums of right plus 1. And then because it starts off like that, we just keep following that pattern. So then nums of right plus 1 is equal to nums of read, so the value at read. And then we're going to have our index for right. So then we want to return right plus 1, which is the length of the array. And hopefully this should work. Okay, it didn't work, so I made a mistake. Let me see where I made the mistake. So while read is less, so our right is equal to 0, our read is equal to 1, while read is less than the length of nums. If the nums of right is not equal to nums of read, then nums of right plus 1 it's set equal to nums of read. So here it says the output was 1 and expected 2. So then let's walk through this. Let's debug it, right? So here we have the number 1, 1, 2. So right was index 0, read was 1. So while 1 is less than 3, the length of the array, if nums of right, which is 0, so it's 1 is not equal to 1. Okay, so 1 is not equal to 1. So then we do read plus equal 1. Now that's 2. So then we say if nums of right, which is at index 0, is not equal to read, then we're going to say nums of right plus 1. Of course, I forgot to increment the right pointer. So that right there, I noticed it because I was like, okay, I incremented read, but then I realized like, oh, I am like doing this correctly, but I'm forgetting to increment my right pointer. So now if we submit it, it's going to work. And that's how you do the problem. And that's also a good little example about how to debug stuff as well, how to think about it. Like, don't panic. It's all good. We walk through how to do it, drawing it out. We know that we have the right answer. So just like the right logic. So just walk through the logic and then in a small example, and then just be like, oh, that's where logic broke apart. We forgot to increment the right pointer. It's a simple thing. But it's very critical because a lot of times you can't forget simple things. So that's all for this time.